Saintsman, we're going to do lesson 11.1 with regard to circumference and arc length. So I'm going to do this fairly quickly and going to consolidate this from the previous instruction that existed. We just discussed circles and in the last chapter with regard to the central angle, inscribed angles, and so a few basics with regard to circles. The big thing is that circumference, C, is going to be equal to pi times the diameter. And I think the more critical way to understand this is the following, is that there is this ratio of circumference to diameter, which is what pi is equal to. So once upon a moon, of course, as you have heard the story before, we have the ancient Greeks take this thing right here. All right, so this just being a circle, they take the chord that goes directly through the center and they figure out a ratio with this line right here, right? This line D. And it always winds up being a little bit over uh, 3 units in as a ratio, 3.1-ish units. And so it's always going to be, we're going to use this Greek letter to signify what that is, okay? So we'll leave pi as pi. That's a critical element of doing this, okay? So let's do some problems. I'm going to find the circumference of a circle with a radius of 11 inches. Okay, so remember that the circumference is equal to pi times the diameter, but you have to remember that diameter is equal to 2 times the radius, right? When we go back up here to this thing, that this and this, these are the radii right here. This length from the center, all right, to the point on the circle. So circumference is equal to pi times 2 times 11, right? Because it's our radius right there, r. So this effectively just is equal to 22 pi inches. It's a linear length, all right? So circumference is going to be linear. We're going to find the radius. Do another problem. Of a circle with a circumference of 4 millimeters. All right. So we're going to find the radius now. So we have C again is equal to pi times diameter. But remember, now we're going to replace C with 4. So 4 is going to be equal to pi, right? And then we need to find out what radius is, which we know radius is going to be, the diameter is 2 times the radius. So we can substitute this diameter with 2 times r. So then we're going to have this guy be 4 is equal to 2 pi r. Now we need to solve this for the radius r. So to get that by itself, I'm going to divide each side by 2 pi. Right? Which means all this is going to factor out. And again, actually, what's going to additionally factor out are these guys. This is going to become a 2. So 2 over pi is what my radius is. All right, so now let's talk about arc length. All right, so we're going to have to, for the following, let's go and get my auto shape. You're going to want your compass for these. So here's my circle. Oops. Yeah, turn that guy off. And I have my circle, which is named O. And I have P on here. And I have Q on here. And I also have point R in the circle. I'm going to draw these radii out. Okay. All right. So, given that my radius is 12, okay, and that this central angle is 100 degrees, we are going to find the measure of arc PR. All right. Now, this wants the arc length here. This is arc length. In other words, it wants to find this distance from P to R, not this degree measurement. Oops. What did I do? There we go. Not the degree measurement, right? We know the central angle is 100, But since we know this length here, we can figure out from the radius using the diameter what our circumference is, and then what proportionally that is. So what we wind up working with is the sector to the whole circle as our ratio. All right, so remember, C is equal to pi times D. And in this case, D is equal to 24, right? Because my radius is 12. So my sector is PR, right? Versus the entire circle is 24 pi, right? That's the entire length around and circumference, right? Because I'm just going to take this 24 and plug it into that diameter. And now we have to figure that proportionally. Well, this guy's going to be 100 degrees of the central angle for the whole circle, which is 360 degrees. And then now we can actually just do a cross product to find PR, okay? And actually wouldn't even do that. I'm going to multiply both sides by 24 pi, right? Because then this is going to factor and this is going to factor. And then I'm left with the arc PR is going to be equal to, and then I can start, I can multiply this guy up. This is going to be, and these degrees are going to factor out too. So I'm going to have 2400 pi, right? 24, clean that up, times 100 over 360. Okay, and now I need to reduce, which I'm going to keep doing that. I'm going to have 240 over 36 pi, right? And then both of those guys are divisible by 12 for sure, right? So let's go ahead and check that on the calculator. Let's see here. 240 divided by 12, right? And then we had 36 divided by 12. So 20 over 3. All right. So 20 over 3 pi. And that's going to be inches. The linear length. Okay. Last thing that we're going to do here today. Oh, is we're going to convert to radians. All right. So we've been talking about that button on your calculator. Okay. And it works like this to go from degrees to radians. Okay. So you're going to multiply degrees. By pi over 180 degrees to radians. All right. If I'm going to go radians to degrees, I'm going to multiply radians by 180 over pi radians. 180 degrees over pi radians. Okay, so let me show you guys what I mean, because this is kind of abstract right now. But this is how you guys do the conversion. For example, convert to radians. Convert 30 degrees to radians. Okay, so I'm going degrees to radians. So I could use this method here on the right, or on the left, excuse me. I got the wrong direction there. So I'm going to say 30 degrees. I'm going to multiply by this, pi over 180. 180 degrees, right? And then of course, like I showed you guys up above, these units are going to factor out here, okay? And then actually this number is going to factor too. This is going to become a 6, right? 30 divided by 30 is 1. 180 divided by 30 is 6. So this is going to be pi over 6 radians. All right? And that is a new type of way for us to measure an angle, okay? I will work with you guys in class. We'll actually talk about tires in class very briefly, and we will talk later. Thanks, Nancy.